For this next example, we are going to fill in the elements on this Venn diagram, and then we're going to look at some unions and intersections and a couple other things. So we're given that the universe is the letters A, B, C, D, E, F, G, and H. Set A contains the letters A, B, C, D, E. B is the letters A, B, and C. And then set C is the letters A, B, and H. Now, hopefully you'll note real quickly that the letters A and B are in all three of these sets. So where all three of those sets intersect in our Venn diagram, I'm going to put the letters A and B. And I'm going to go ahead and cross these out just to indicate that I have used them already. Now, sets A and B also share letter C. So here, where A and B intersect, but it's not also part of set C, I'm going to put the letter C, ironically. We are now done with set B, so we don't need to write anything here, and we don't need to write anything in the overlap between B and C. Similarly, set C, we've used up, oops, no we have not. I got ahead of myself. Sorry, for set C, we do have one letter left. Letter H. Letter H is not contained in set A, it's not contained in set B, so we're going to put the H here. Now we're done with set C. Now moving to set A, we have the letters D and E, which are unique to set A, so I'm going to write them up here. Now if I go back to the universe, the letters F and G are not part of set A, they're not part of set B, they're not part of set C, so I can put them anywhere in this rectangular box just outside of the three circles. I'm going to put them in the corner up here, though you could put them anywhere you like. So now we'll answer a few questions. The first one is asking for the union of sets B and C. So this is all the letters in set B and all the letters in set C. So we're dealing with everything in circle B and everything in circle C. I'm going to write these in alphabetical order, though you do not have to. So it's going to be the letters A, B, C, and H. So that's everything in B, everything in C. Part B is looking at the intersection of sets A and B. So the intersection of sets A and B, that's where they overlap, and they overlap in kind of this football-shaped area here. And the overlap contains the letters A, B, and C. That's what's common to those two sets. Part C is asking for the intersection now between sets B and C. So again, it's this football-shaped space between sets B and C, and that contains simply the letters A and B. For part D, we're back to sets A and B now, but it's asking for the union. So that's everything in A and everything in B. So that's going to be the letters A, B, C, D, and E. And then the last two. Part E is asking for the complement of set A. So that's everything that is not part of set A. Set A contains the letters A, B, C, D, and E. So the complement cannot contain those 5 letters. The complement is going to be the letters F, G, and H. And then the last one, it's the union of set A with the intersection of sets B and C. So following typical order of operations, I'm going to start with my parentheses. The intersection of sets B and C are the letters A and B. That's the intersection of B and C. So I want set A unioned with those two letters. So that's everything in set A plus these two letters. So we're looking at A, B, C, D, E once again. Now I mentioned following order of operations, work in the parentheses first. A lot of the properties that we use with numbers also hold true for sets. So the transitive property holds through. If A is a subset of B and B is a subset of C, then we can say that A is a subset of C. The commutative property holds true. Commutative property, if you're looking at the union or the intersection, it's telling you the order doesn't matter. If I say A union B, it's the same thing as B union with set A. The associative property also carries through. The associative property is what lets us move parentheses around. So if we have all unions or all intersections, we can move our parentheses, and that's just going to indicate what part of this problem we're doing first. The empty set, that's the idea of adding 0, so it's not going to change anything. And then we also have a distributive property. So here we have A intersected with the union of B and C is the same thing as the intersection of A and B unioned with the intersection of A and C. And we have basically the reverse of that for the second line. So we have these very similar properties. Now, what we're going to do here to wrap up this section is we're going to consider 3 sets, A, B, and C, and we're just going to shade what is being highlighted. So here I have the intersection of A and B unioned with set C. So the intersection of A and B is this area here. It's where A and B overlap. And that's unioned with set C. So plus everything in set C. So we're dealing with this area. Now moving to the right, I have the complement of A unioned with the intersection of B and C. So the intersection of B and C, where B and C overlap, we're dealing with this. And we're going to union this with the complement of A. So the complement of A is everything that's not part of A. So when we deal with the complement of A, it's all of this out here. And then it's the part of set B that does not overlap with A, and the part of set C that also does not overlap with A. So this is a larger area that's shaded for the second one. Moving down here to the bottom left, we're looking at the union of A with B, also with C. So this is everything in A, everything in B, everything in C. So basically we're just going to shade all 3 of the circles in their entirety. So that's the union of all of them. Then our third one, it's the intersection of the complement of A with B with set C. So this one is a little trickier. Let me start with the complement of A, and I'm going to go to a different color here. So the complement of A is everything that's not part of A. So all of this. Okay. And then we're going to intersect that with set B. So where does this overlap with set B? Well, it's going to be this bit here. Then we want to intersect that with set C. So now where does this green area overlap with set C? Well, just this bit down here. So this one ends up being the smallest shaded area of all. And that's going to wrap up this section.